and welcome to this class. In this class, we are going to clear the concept which is a little difficult for some of the students who are preparing for CSIR. So basically इसमें हम concept ही clear करेंगे आपका. तो इसमें हम बात करेंगे हाइड्रोफिलिक मॉलिक्यूल्स और हाइड्रोफोबिक मॉलिक्यूल्स. ओके, तो सबसे पहले बात करेंगे हाइड्रोफिलिक मॉलिक्यूल्स. हाइड्रोफिलिक मॉलिक्यूल्स वो मॉलिक्यूल्स होते हैं which love water, means they can dissolve in water and they can attach themselves or dissolve in water. Okay. So second is hydrophobic, means they fear the water. वो वाटर में कभी डिजॉल्व नहीं होंगे, बट स्टिल दे कैन एग्रीगेट विद ईच अदर in if we place them inside the water. Okay, so the thing is, in hydrophilic molecules, which is water loving molecules, they have polar covalent bond formation whenever they attach with each other or with water. Okay, and the atoms have high difference of electronegativity, that's why they can form polar covalent bonds. While in non-polar case there is no electronegativity difference, but still they can form non-polar covalent bonds with each other. Okay, now the polar groups are partially charged and act as dipole, and example of which are OH, okay, oxygen and hydrogen bond, nitrogen and hydrogen bond. Okay, and in case of non-polar groups there is no partial charge between them, not between but in the case of both the atoms. Like if you form CC bond or CH bond, there will not be any charge, that's why they are not polar, that's why we call them non-polar molecules. Okay, and if you talk about polar molecules, okay, polar molecules, so polar molecules need some protein carriers in order to pass through plasma membrane, while non-polar don't need any carrier to pass through plasma membrane. They can directly cross the plasma membrane and enter into the cell. Okay, and the role of this polar molecules, okay, this side is polar and this side is non-polar. Okay, and the role of the polar molecules are in forming the hydrogen bond with water molecule or polar macromolecules of the cells, while the non-polar molecules, they form lipid bilayer of the cells. You know how important it is, like whole cell needs lipid bilayer, I'm really sorry, needs lipid bilayer to maintain its shape, to protect the inner content from external. Okay, so that's why lipid bilayer formation is very important. So non-polar molecules are very important, and similar thing goes for the protein of folding of proteins and nucleic acids also. In those, non-polar molecules also play their role. And if we dissolve polar molecule in water, then what change will we get is that Gibbs free energy gets negative, and this negative energy will show that the reaction is spontaneous. That means these water molecules and our polar molecules can dissolve in a good way, and this process is exothermic. While in case of non-polar molecules, Gibbs free energy gets positive. That's why they generally don't don't dissolve in water. But if you give some energy to them, then they can of course dissolve, because giving the energy can change the Gibbs free energy to negative. Okay, and of course the entropy is increased when polar molecules dissolved in water, while the entropy will decrease if we dissolve them in water, non-polar in water. Okay, and the examples of the polar molecules are iron and salt, while examples of non-polar molecules are oils and waxes. And as I was talking about Gibbs free energy, so this Gibbs free energy is actually shows us, its value shows us how spontaneous the reaction is. Okay. Now spontaneity means if the reaction is possible or not. Like A plus B, if they will form the product C or not. This is what the spontaneity shows us. If it is a spontaneous reaction, then yes, these can form C. But if it is non-spontaneous, then they will not mix themselves. A and B will not mix by themselves. Okay, and they will not form C unless we give them energy. Okay, and the formula of the Gibbs free energy is here. Delta G is equal to delta H minus T delta S, where delta G is change in Gibbs free energy, delta H is change in enthalpy, T is temperature in Kelvin, and delta S is change in entropy. Okay, and if the value of delta G is negative, have I written it here? Yeah, here it is. If the value of delta G is negative, then the process is spontaneous. While if the value of delta G is equal to 0, which means rate of forward change is equal to the rate of backward change, means A plus B, and will give C, but C can also transform into A plus B, okay? That is what equilibrium is. While if the value of delta G is less than 0, which means the value is positive, then the reaction is non-spontaneous. That's it for today. Thank you very much and see you soon.